All right, well, I'm glad to see everybody. Let's go ahead and kind of map out what's going on. I'm glad you're here. It's Friday. We have, can you take your coat off? And we have next week, today, I know what we're doing, and Monday we're going to get close to finishing, and then we're going to, I won't see you on Tuesdays, and then Wednesday you actually have the PSAT, but that's in the morning. And so on Wednesday, I actually will see you, and that's when we'll be getting very close to finishing up the chapter. And then I thought Thursday, I went ahead and moved your test to Friday, so we would actually have a whole day. We could have a whole day to review and things like that. Now, I could give you a small quiz somewhere along that way. You see that? So if I gave you a small quiz, it'd be like you don't know what day it would be. It'd probably be a 10-minute quiz just to make sure you're kind of studying this material. I don't want to wait till next Friday to figure out that you haven't been doing your stuff, okay? All right. So that's how I'm going to map this out, okay? All right. Let's go to, if you have your packet with you, I do need to get going here because I want to have enough time that even if we want to spend some time with the homework questions later, we can do that. You guys, I'm proud of you because I do want to teach chemistry. I don't want to teach some watered down thing. I don't, just because it's non-honors, it doesn't mean that I'm not teaching chemistry. And I simply, what you're going to notice is that we'll certainly take a little longer than the other class, but it's the same kind of material. There's might be some things I don't do. There'll probably be a couple chapters you won't do at all. But you'll do all the same labs that they do. Got that? So you do everything they'll do, except maybe a couple chapters. Because I'm going to take a little longer to do what we're doing. Now, this right here, this idea is kind of high level. It is kind of high level, and it was called significant figures. Remember this? Now, significant figures have to do with the idea of measurement. That's why your math teacher never talks about them, because what kind of numbers do they use? They don't use measured numbers. What do they use? I know you're looking for some kind of special name, but they use what they call perfect numbers, theoretical numbers. Like their 5 is 5.000 to infinity. There's absolutely no error. It's theoretical. You good? But if I give you a ruler and you measure something and you say it was 5 centimeters long, that's not theoretical. That was measured, wasn't it? And if I were to give you a better ruler, instead of saying 5 centimeters, you might say 4.99. So 5 is not necessarily 5, is it? With a better instrument, it might be 4.9. You need to know that because every time scientists measure numbers, there's always a little bit of error. Now, you and I can live with error. There are people who have atomic clocks that measure millionth of a second. I don't need millionths of a second, but they do. The experiments they're doing, you have to be accurate to millionths of a second to learn what they want to learn. Most of you have on your phone some kind of a GPS device, and it tells you where you're at. If that didn't, if they didn't use clocks that went down to below hundredths of a second, they go down close to millionths of a second to figure out where you're at. It used to be when they first came out, and they had these satellites, they could say, well, I know within about a quarter of a mile where you're at. And then it got really good when they said, I know within 50 feet where you're at. Well, now they know pretty much within about 3 feet of exactly where you're at. See that? And that's all about timing. The computers you have, you know what they call speed, computer speed, like they have so many like gigahertz and stuff like that. You can have the speed at which your computer takes in information. That's all timed way below anything. You wouldn't worry about those kind of timing issues, but they have to. They couldn't make computers if they didn't. So significant figures, excuse me. Significant figures are things we have to live with. If you're talking about measured numbers, you have to live with them, and you have to understand them. And we did these the other day, and I thought we'd just kind of, if you don't mind, let's do a quick review. Let me go ahead and start the camera. Oh, I know. You start the camera. If you have your handout sheet, we're gonna go way back here to this one, and this is just reviewing. These should be, if I have 5 of these on the test, you should be able to get all 5 of them right. Yes?
I have my locker,
What is?
my packet.
Really? In your chemistry, not in your chemistry binder? Yeah, go get it. All right. Everybody have this page out? Now, so if I give you 5 of these are some of the 5 of the easiest questions that I'm going to ask on a test. For example, what if these had units after them? They should have units after them, but what if you had to tell me how many significant figures there are in this one? So why don't we start here with Daniel? We'll go down the row. What if this had a unit after it? How many significant figures would you say that one has?
Which one?
This guy right here.
4.
Okay, what do you think? Okay, let's go back to the rules. Rule number 1 says if you're not a 0, you're in. Is that okay? Rule number 2 is the Oreo cookie rule, isn't it? Now, which one is trapped? This guy's trapped. Now, look at this guy here. He is a trailing 0. Are trailing zeros significant? Sometimes they are, sometimes they're not. And that's a fine point, isn't it? Is this 0, it's trailing, it comes after the 4, but it only counts if you see a decimal, and I don't. So in this case, that's not significant, and I only had 3. Okay, Layla, you're next.
3.
Right, there is no rule for these zeros. I don't even teach that. So here's 1, and here are some trailing zeros, and there's a decimal, so they're in. All right, next, May. Yeah, that was easy. All of them are not, none of them are zeros, right? All right, Zach, how about the next one? What about a number in scientific notation? Okay, and we only look at this part of the number, and these are trailing zeros that come after the 2, and there's a decimal. So what'd you say? Okay, 4, right? All right, next. Kyle, what about this one?
I said 5.
How many?
I said 5.
Right. Certainly these are, in the Oreo cookie zeros, these are trailing, and there's a decimal, so very good. Back up to Madison. Right. These are trailing zeros, but there's no decimal, so only these. All right, next. One more. That was easy. Okay, 2. And this one's a little bit harder, Sierra. How many?
Do you count the zeros since it's a decimal?
I can't hear. I'm sorry.
Do you count the zeros since it's a decimal?
Okay, now wait. What? Remember the 3 rules? When you say, do you count the zeros, which ones? Now, for example, we know if you're not a 0, count.
Yeah.
We know if you're a 0 trapped between 2 sig figs, you're in. So I know about that. That's that one. Now you're asking about these, aren't you?
Yeah.
They are trailing zeros, but there's no decimal. Oh, there is? My fault. That's my fault. I couldn't see that. You're right. So they count. So they're in. So 1, 2, 3, 4, 5, 6, 7, 8. Woo! Now, even though somebody made up this sheet, it would have been an incredible instrument to give you 8 significant figures. It would be, what kind of instrument can give you 8 sig figs? That's really a very expensive instrument, okay? All right, and the last one, last 2, back up to Daniel.
Would be
Okay, now remember, in a scientific notation number, you don't have to look at that.
so it's on
3, okay? And Layla, you got the last one.
3.
Right. See, if you say to yourself, I really do know this, and I should be fine with this. If I give you 5 questions on there and say, bang, 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 get that? Now, let me tell you one that will trick you, okay? I'll even tell you ahead of time which one is going to trick you. What if I say 5 books? 5 books. How many significant digits in that? Can't find it?
No.
How many? 1? What do you think? What? Right. You see, this is the same numbers I use in math class. These are counted numbers, right? Counted numbers are perfect. They have 5.0 to infinity. This one has an infinite number of sig figs. You get that? And it has it on here, little stories over here about that. Okay, so now, is that a good review? So that wasn't a measured 5. It's like, hey, there's 5 books. Oh, wait a minute. Give me another measuring instrument. Maybe it's 4.9 books. No. What can't be 4.9 books, can it? All right, next. This is what we did yesterday. And remember I told you that here's what happens in math class. You multiply this, and you get this number here. But the calculator is so stupid, it doesn't even know that this is a centimeter times a centimeter times a centimeter, and that gives you a centimeter to the 3rd power. Isn't that also cubed? Isn't that a centimeter cubed? Okay. Your calculator is so dumb, it doesn't know that these were measured numbers. And so he doesn't know about sig figs, but you do. And you know that when you multiply or divide, when you do calculations with significant figures, I don't mean in math class. In math class, you write down the exact answer. You get that? But when you do things with measured numbers, like in science or engineering, you have to round to the least number of sig figs. So let's take a look at this. 3 sig figs, 3 sig figs, 2. So I have to look at this answer here, and I have to round it to 2 sig figs. So there's the first 2, right? Now, if you round to 2 sig figs, do you ever look at the third one? I'm looking at everybody's faces, or half of the faces. Do you ever look at the next one? You have to. And he's big enough. What's underneath my finger, the third one? He's big enough to make the second one turn to a 9. Now, you can't just round it off at 19. There's nobody in the world, if you had $188,000, you'd say, round that off for me. Okay, 19. Oh, something's not right. So you do have to put these zeros here so the 1 and the 9 stay where they're supposed to be. But I didn't put a decimal, did I? So how many sig figs does this guy have? 2. And that's what you told me to. You said round it to only 2 sig figs. All right. Did we do all these yesterday? Not all of them, right? Okay. So here's what happened here. Look out here. We did this times that. And your calculator said this, but the calculator didn't know that a meter times a meter is a meters to the 2nd power, meter squared. That's area. Meters is distance. Meters to the 2nd power is not distance. It's area, flat area. And what's a meter to the 3rd power? That's called volume. When you see meter to the 3rd power, it does not mean distance. It means volume. Anyway, so they're measuring area here, and this would be a lie. Not in math class. In math class with perfect numbers, you'd write this down, wouldn't you? But if you know you measured that, you'd be lying to people. You said that's the answer because look at your weak link. Your weakest link only had 3 sig figs. So we have to go to 1, 2, 3 sig figs. I'm going to look at the 4th one. Not big enough. So I write 3.33 there. Look about this. The rule for multiplying and dividing is the same. So I had 4 sig figs, 2. Here's what the calculator said. 2 is my least number. Peak. I'm bigger. And that's why I had to turn it to 25. Are you with me? I got to look at you. All right. So let's do one we haven't done yet. Let's do number 4. So here your calculator out. Did somebody borrow my calculator yesterday? Because mine's gone, and I know it's either this class or the next class. Okay, nobody borrowed it? All right. All right, put this in a calculator, and then write down what the calculator says, and then I want you to round it off to what you consider to be the right number of sig figs. Now, if you're, everybody, you guys should bring your calculators, okay? So take this minus that, put your answer the calculator gave right there, and then round to the correct number of sig figs right there. Do you have a calculator?
No.
No? Okay. All right. Zach, you got done? Okay. You guys got to, you should be, your 10th graders, right? We should be a little more, get it done, okay? Like right now, everybody should have this in a calculator and you should have written it down. The hard part is going back up to the rule, figuring out what to round it to. All right, Zach, ready? What do you have? What did the calculator say the answer was?
26.5.
Start again.
26.56.
Okay, and a gram minus a gram is just grams. Is that right? All right, 20 apples minus 3 apples is 17 apples. Okay. All right, what are you going to do, Zach? What if you use the rules up here about significant figures, what are you going to round it to?
27.
How much? Just 26? And what?
I said 27.
Oh, 20 what?
27.
Oh, 27. Sorry. I'm sorry. I'm asking. Bother me. Well, let's see if he did this right. This was a subtraction problem, and it said here you don't actually count sig figs, do you? You count decimal places. So this goes to hundredths place. This goes to tenths place. So you have to round it to what? Zach. This goes to hundredths place. This goes to tenths place. What are you going to round it to? Tenths. Okay, so we look at tenths place. See the 5 in the tenths place? I have to round to tenths place. That means that 5 either stays the way it is or it's going to go up. So I look at hundredths place. Watch now. I'm big. I'm big enough. So now you have to write 26.6. 26.6. So I'm glad we're doing this. When we're doing these, we're kind of reviewing, but if you've only seen it once, if you don't make yourself review it, you don't have it. You don't know it if you don't review it and say, I know what I'm doing. Okay, so I want everybody on number 6, put this in a calculator, and I'll call on somebody, and I want you to round it to what you consider to be the right number of sig figs. And if you start doing these, you start getting them right. You said, now I got it. I got this now. Okay, Madison, what do you have? What does the calculator say that you should write down?
3.351.
3.351? And what kind of units?
Centimeters.
That's right. And are you going to put that down here? So you're going to leave this the same answer, right?
3.35.
3.35? Okay, so let's take a look. This was an addition problem, and you don't count sig figs here, it's count decimal places. So this was hundredths place, thousandths place. So you're around to hundredths place, right? Let's take a look. That's ones place, tenths place. The 5 is in the hundredths place, isn't it? Now, is that 5 going to stay as a 5, or is it going to go up by 1? Well, I got to take a peek. And my peek says that's not big enough, right? So you did it right. Good job, Madison. 3.35 centimeters. No problem. Okay. Okay, now let's do the next one. Let's everybody do number 8, and I'll call on somebody for that one. This is our last one. So put that in a calculator and then round to the correct number of sig figs. All right, Isabella, ready? I know you have a mask on, but as loud as you can, tell me what the calculator said. 54.75? Now, what kind of units should you have? Okay, so I'll put that here. What did you round it to? Can you help me out and close that door, please? I'm sorry. What'd you round it to? 54 point what? 8, okay. Let's take a look. This is an addition and subtraction type thing, right? So you don't count sig figs, you actually count decimal places. So this is the ones place, this is the hundreds place, so I need to round to the ones place. Now let's go find the ones place. You see the 4? The 4 is in the ones place. But that 7 is big enough to do, so what do you think the answer is? Right. So it would just be plain old 55 kilograms. Now, I know you don't do this in math class. I'm not your math teacher. I'm trying to teach you what they do in science and engineering. And when they use measured numbers, we have to have a set of rules. That's the way it is. Otherwise, you're lying to people. Okay, that's enough for that page. Now what I'm going to do is, this is a very short lesson. We'll do this one. Whoops. Oh, this says E class. Let me go back to your class. Okay, here we go. Let's go to this page right here. Now, what you're going to notice is that in your book, I also on the back page of here, they have these 2 words, and anytime you have a chapter on measurement, if I went to college and I took physics class, in chapter 1 or something, they'd have something about measurement, and they would use these words, accuracy and precision. I was talking to Miss Frowns the other day, and her son is at UVA, and he already got his undergraduate degree in chemistry, but he's actually teaching the first year chemistry students at UVA. Okay, because he's trying to get his master's degree. They're paying for him to get his master's. And he said, well, the other day we're doing a lab. He says, yeah, tell Mr. Feeney to keep doing that significant figures and accuracy and precision, because they act like they didn't know what that was. And again, you don't know what you're going to be doing. You don't really know that you won't take a science class in college. You're not really sure about that. So these 2 words, a lot of times in the U.S. especially, we kind of think those are the same things, don't we? Hey, is it accurate? Hey, is it precise? But there's a difference, okay? And I'm going to show you what I mean. A lot of times I like to use targets in science books, and they have an analogy. And they say, what if you threw a dart and it came over there? Do you think that dart was thrown very accurately? And you say, no. Why not? How would you know? How do you know it's not accurate? Well, because I was taught a long time ago that you're trying to hit the bullseye. And that wasn't that close. Okay, so why do they have this in a science book when I've never done a science lab where you aim for a target? Because here's what it's going to look like in a science class. These are your darts. You're going to do an experiment, and you do it 4 times. Now, see these? These darts. Now, because you did it 4 times, you're going to find the average. Let's do that right now. Take your calculator, add these 4 up, and divide by 4. Add these 4 up, and divide by 4. And then write that down as the average. What was your average dart? So add them up, divide by 4. Now because these only go to hundreds place, you have to round to hundreds place on these. All right, so add them up, divide by 4. Write that down. All right. Delaney, you got it for me?
Is it 73.09?
One more time.
73.09.
Did everybody get that? All right, so the average dart, and there's the data points, aren't they? Is this one. And what I want to know is, was this accurate? And I want you to pay attention, because how in the world do I know this dart's not that accurate? Because I knew what the bullseye was. Now, what about in science? Hey, 73.09, what do you think? Hey, pretty accurate? How would I know? You have to tell me the what? You have to tell me what the bullseye is. Now, what is the bullseye in science? They have many names for it. One of them is called the known. If it's the known, then that's your bullseye. That's what you're trying to get. Another word they use, it's the standard. All right, what's another word that means bullseye? The accepted value. If I look in a book and it says the density of something is 2.5. That's the accepted value. And then another one is called the true value. They all mean bullseye. So now, take a look. Is this accurate? You say, I don't know. Oh, yeah, you do. But look right here. What's it say the true value is? You're supposed to get, in this experiment, you're supposed to get 73.00. What do you think? Were they pretty good? I think they did pretty well. They're supposed to get 73.00. They got 73.09. That's pretty good. That's very good. Now, what we do is, and I know you can do this, we have labs in here, and I'm going to ask you to find out how accurate, when you do the experiment, I'll say, how accurate were you in your experiment? You say, well, how am I supposed to know? I will have to tell you the bullseye, won't I? Now, how do we do it mathematically? Now, I printed it on the other side of the paper. Okay? So I couldn't fit it on the other side, but here's the way scientists figure out whether or not you are accurate mathematically. Now, I know you can do this. I wouldn't even ask you to do it if you couldn't do it. It's called percent error. And percent error is used to find out accuracy. Everybody get that? So percent error is what you have to do. So if you do an experiment, I'll say, I want you to find your percent error. You're going to use this equation right here. Now let's take a look at it. It looks like a kind of a, I don't know, threatening equation. It says here, take the experimental value. Now, what do you think the experimental value is? Sierra, what do you think? Say it. You were getting ready to say it. It's what? Not necessarily a guess. I bet, did you have to do the what? You had to do the experiment, right? The person I showed you on the other page did the experiment 4 times, and we found the average, didn't it? That was that person's experimental value. Now, so if we want to plug that in, let's say we're going to do that. What did it say, 73.09? Is that what it was? Okay. Now, what is this right here? Look at this, the accepted value. That's the bullseye, isn't it? Isn't that the same as the true value? And so what was the accepted value? Remember on the other page? What were they supposed to get? Everybody with me, okay? What do you think? Look at what we got. On the other page, what was the true value? Everybody got that? That was pretty easy. And now you divide by what? See, if you subtract, it says, how close to the bullseye were you? That's called error. But then you divide by the bullseye and you get percent error. Okay, so let's divide by the bullseye. And then what's going to happen is, if somebody will go ahead and put that in a calculator. Now, you guys, your math teachers taught you about order of operations, haven't they? PEMDAS? Okay, your calculator is made to do certain things before others. So if you put parentheses around that, it will subtract first. But if you don't, it won't subtract first. So you say parentheses 73.09 minus 73 parentheses divided by 73. Okay, now I need somebody to tell me what they got on that one. Daniel, what'd you get? Just
I got .00123.
okay. Now I want to show you something. That is the decimal version of percent. And you probably had a math teacher who told you this. 0.50 is the same as, and you move the decimal over 2 places, 0.50 is the same as 50%. Isn't that right? Well, guess what this does? When you multiply by 100, guess what it does to the decimal? It moves it over 2 places. So don't worry. See, and now you know why it's there. So Daniel, your final answer is, you're going to multiply by 100, you're going to get 0.123. Is that what you got? Okay, so now let's go back on the other side. And what was the person's percent error? 0.123%. I'm telling you, that is really close, isn't it? It's not 1% error. It's only about 1/10 of 1% error. That is tiny. This guy was really accurate. Maybe it was a girl. Okay, now what I'd like you to do is, I'd like you to do student number 2. Do student number 2 and see if you can find a percent error for student number 2, okay? Let's do that now. Do everything we just did with student 1, do it with student 2. Now, there is a tricky part because you can't go past hundreds place here. You get that? You have to round to hundreds place here. So that's going to trick you a little bit. Now, after you get this average right here, then put it into the percent error equation and find the percent error for the student. I'm sure you've heard on television when they talk about, well, the percent error was less than 2% or something like that. That is pretty good. All right, let me are you all done, Madison? All right, who haven't I called on for a while? Zach, you don't have a calculator. All right, May. What'd you get up here?
71.995.
Okay, now, because of sig figs, you can't go past hundreds place, right? When you add these up. So here's hundreds place, but watch now. See that 5? Ooh, I'm big enough. That makes that a 0. That makes that 10. That makes that 10. And so if I have to round it to hundreds place, it has to be 72.00. That's a little tricky, wasn't it? Okay, now, can you put in the percent error equation now? Put 72 in there. So you're going to have 72 minus 73 in parentheses. And then you divide it by the bullseye, that's 73, times 100. Okay, May's going to tell me what you got, and then we're going to check it. What do you got? Let's try it again. Parentheses, 72 minus 73, parentheses. Got that? Now divided by the bullseye, 73,
Yeah, that's what I did.
times 100.
Oh, time.
So you get like 1 point something, or
Is it 1.3698631?
okay, that's going pretty far there. 1.36 what?
9,
What's the next one?
8.
Okay, I'm gonna say this. Okay, all right. So what we see here is both students did incredibly well. One of them had only about 1.4% error, and the other one had 0.1% error. I'd say they both were pretty good, but if you ask me who was more accurate, I'm gonna have to give the star to this one here. Get that? Now, when you see in science books where they throw the darts, you'll see something like this. Now, of the 3 darts, one of them wasn't too bad, right? But you know there's something wrong with the dart throwing machine because it could just as easily gone here as here. I don't know if any of you ever shot guns at targets. Any of you ever done that? Okay, and what you do is if you're trying to hit that bullseye and you have a scope on and you go boink, 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 somebody's going to say, you know what? Yeah, I know one of them was close to a bullseye, but you're not really that good yet because you don't have, not accuracy. I know you don't have the accuracy. You had a little bit of accuracy here, but what are they looking for? Watch. Kyle, if you shoot like that, what do they say? What words do they use? Group. If you have a tight group, then that is called precision. Now, do you notice that precision has nothing to do with the bullseye? I didn't ask you if you're accurate. I said, were you precise? And you know what? Oh, yes. You were very precise. Now, Kyle, the next thing they're going to ask you to do, what are they going to ask you to do? If you put 3 right there in a really tight group like that, they're going to say, you know what? You're good, very precise, but what are you going to do?
Probably adjust your scope.
You're going to adjust the scope. You see that? Do you believe that's what they do in science? They have these great machines that cost a lot of money. And you know why they cost a lot of money? Because they're precise. But machines are dumb. You have to tell a science machine, sometimes you have to do what they call calibrate it. That's what you're doing with your scope. You're trying to calibrate your scope. You're trying to say, I want this. What I really want is precision and accuracy. See that? And that's what scientists do, really. If they were to take some of your blood and send it down to, there's this place called LabCorp. It's in Burlington. They make lots and lots of money testing people's blood and urine and stuff like that. Well, they have this really nice machine. And when it comes in there and they put your blood in there, how can they say that you had this much iron in your blood? How in the world does a dumb machine know that you had that in there? And here's what they had to do. They have it's a very expensive, precise machine, but it's dumb. So what they do in the morning, they would take something that they knew had no chemicals in it, none. They put it in the machine, and everything that reads, copper, zinc, whatever they're looking for, iron, 0, 0, 0, 0, 0. They're telling the machine what zeros, you get it? And then they have this really expensive sample that 3 different laboratories have confirmed. That's how much iron's in it. That's how much iron's in it. They confirmed it. It's a standard. They put the standard in the machine, and it says, here was 0, and here's 50 iron. And then you put your blood in there that day, and it comes up halfway. And what does the machine spit out? Here's 0, here's 50. Your blood was halfway up there. What are they going to say? 25. That's how they do it. They have a precise machine, but they have to let it know what the standards are, and then it can be also accurate. You had a great scope, but you had to standardize it or calibrate your sights. Now, I don't know if they call it calibrate or what do they call it? You have to adjust the sights or something like that. So really, it's kind of interesting that that's what people do anytime they're trying to get precision and accuracy. I don't have, in a 10th grade, I don't do the mathematics precision, but I do want you to take a look here. You don't have to know the bullseye to do precision. You see these? How close are they to themselves? How close are these to themselves? How close are these to themselves? Take a look right here. Hey, May, can you come up here? Look up here at me. Okay. Now, look right here. The average for this person was 72. How far away was that from the average? Like nothing. 0.01, 0.01. Look how close it was to its own average. I don't care what the bullseye is for precision. And look at this one. His average is 73.09, but you can see where he's a little bit up and down. You see that? I'm not going to do the mathematics for you, but if I do it on a test, I'll make it really obvious. These are closer to themselves. You get it? Only the bullseye only counts for accuracy, not for precision. Okay, you okay on that? All right, the last thing we're going to do is, and we're going to have plenty of time to review. We should have plenty of time to review. Let's go all the way to this page here. I thought we would start this lesson. It's about 7 pages in your book. They have 7 pages in your book about temperature and temperature scales. I believe that in about 10 minutes, I can teach this to you, and you don't have to read the 7 pages. Got that? All right, so you know that temperature is something that might be measured in here. You guys, we have that with you guys. The next lab we do, one of them is you do measure temperature. Now, this right here is called the Fahrenheit scale, and it's the one that we use in the United States, right? I don't know if I don't think anybody in the world uses it except for us. Used to. England used to use it. Canada used to use it, but no. 1965, 1970, they switched over. They don't use Fahrenheit anymore. Nobody really cares about Fahrenheit except you. Now, this scale is called the Celsius scale, and the whole world uses it except for you. You got it? Every science lab, every engineering, if they're doing temperature, they have a Celsius thermometer. You get it? So everybody, even in the scientific community, uses Celsius. Everybody in the world uses Celsius for everyday language. And this right here, we'll talk about that later. So let's just talk about these two, all right? Now, I'll bet, if without looking, how many things can you tell me about your favorite lovey-dovey Fahrenheit scale? Can you tell me anything you know about it? Without looking, give me something you absolutely are sure about on the Fahrenheit scale. You have one? Something you're certain about? What do you think? Yes?
Like the numbers are higher than Celsius.
Yeah, but don't tell me that. Act like you don't know what Celsius is. Tell me something that you know about the Fahrenheit scale. When it's this temperature, that's this. Do you know what body temperature is?
Oh, like if it's 32,
What's body temperature in Fahrenheit? See? Isn't it interesting? You act like, well, I don't like the Celsius scale. Well, you don't even know the Fahrenheit scale. Do you know body temperature in Fahrenheit? Do you? Really? So when they hit you with a gun, a thermometer gun, what are they looking for? What number are they looking for? 98.6 is normal, isn't it? 98.6 is normal. I think you should know that. Okay, now, I'm going to change this number here to 72, by the way. What's a comfortable room? Today, the high is around 72. This room is nice and comfortable, and you should know that. A comfortable room is somewhere around the 70s. All right? Some people like it warmer. That's okay. In the winter, I might like it in the 80s, low 80s. Got that? That's pretty hot, though. Plus, you have to pay for all that. What else do you know? Without looking, do you know anything else about the Fahrenheit scale? What about water freezing? Do you know that one? And really, you're opening my eyes a lot. You act like you know the Fahrenheit scale, but you don't even know when water freezes? All you have to do is wait till the wintertime and watch the weather report and say, well, it's getting below 32 tonight, and it's going to have some water, some rain. What does that mean for you? School delay. Why is the school going to be delayed? Because water freezes at what temperature? 32. You should know that, honestly. And if it gets down to 30 and there's rain overnight, it's going to freeze on the roads. It's going to be really slick. Okay, most students know 32. That's weird. You don't know that. Here's one they don't know. Most people don't know what boiling water is in Fahrenheit. I'll give you that. That's 212. Aren't these weird numbers, aren't they? They're weird. Weird numbers. Do you know what absolute zero is in Fahrenheit? I have no idea. Now let's go to the Celsius scale. Ready? Do you remember something in middle school that they taught you about the Celsius scale? And by the way, they made the Celsius scale because they wanted to be easy to use. Easy to use. It's even based on powers of 10. All right, did anybody know those? In middle school, they teach you that water freezes at what? Wow. I'm going to go ask her. If she taught that, and you guys just, right? Water freezes at what on the Celsius scale? They made it easy. 0. Water freezes at 0 degrees Celsius. And water boils at, they made it easy. It's some power of 10. 100. Wow, I already like the Celsius scale. I can remember 0 and 100. I already like it. Okay, let's do this one. What's your body temperature if you went anywhere in the world except for the United States? What do they know? If I go ask an exchange student from China, hey, what's your body temperature in China? Just like that, they tell me. Everybody in the world knows their body temperature in Celsius except for you. So what I'm going to do is I want to show you some things. And look at this right here. Everybody see this? This is an equation that you're going to eventually have to memorize. I'm going to show you how to memorize it. It's a stupid 6-second song, okay? And the stupider the song, the more you remember it. Okay, so I'm going to help you do this. A long time ago when I first started teaching, like over 45 years ago, and I taught this to an eighth grade class, I think it was, and then I never used it the rest of the year. And then next year I had to teach again. I said, well, I better get the index card out. I didn't remember this. I didn't have it memorized. And I said, oh, that's kind of dumb. I'm a science teacher. why don't I go ahead and memorize this, all right? And so I said, well, how am I going to memorize this? And I have no idea where it came from, but somewhere in the back of my head, this stupid song came up, okay? Now, by the way, it's stupid. Okay, I'm going to even stand up and do it for you. Now, what I'm going to do is I'm going to get the beat going a little bit here. And it's kind of like a rap song, but now, I was rapping before MC Hammer. But I didn't know it was a rap. I just thought it was a stupid song. So, getting there. First thing you do, subtract 32, 5 nights. Yeah. Okay. Well, anyway, it's a 6-second song. It's very stupid, but here's how you memorize this equation. Ready? Dun, dun, dun. The first thing you do, subtract 32, 5 nights. Yeah. I did it. Now, so anyway, since I live in the United States and they're always giving me Fahrenheit, I can plug that in and it'll turn it into Celsius. You get that? So I want you to do that right now with your calculator. I want you to know what is normal body temperature to everybody in the world except for you. And you should know it. How many of you have been out of the country? Missions trips? Okay, you probably never asked anybody what normal body temperature was, did you? Okay, let's find out. Let's find out what normal body temperature is around the world. Calculator, right? Calculator. Let's do it. Got it? First thing you do, subtract 32, 5 nights. Yeah. Do you guys have any foreign students in your class in the 10th grade? How about 11th? Actually, a lot of foreign students, they weren't allowed, if they went home, they weren't allowed to come back. They'd have to be in quarantine. Now, James Bean, he didn't actually go back, did he? Okay, but I think he's a remote student, though. Did he? Did he go back?
He might have. He's taking it online right now.
Okay. Wait. This is the first year we haven't had quite a few international students. All right, ready? Let's see. Delaney, what'd you get? Everybody in the world knows that their body temperature is what number?
Wait, was I supposed to divide 96?
Okay, yeah, 98.6. Put that in there and say first thing you do, subtract 32.
Yes.
And then times 5 nights.
Oh, times 5 nights?
Yeah, see that? That means time. Everybody know that means multiply? If you don't see add or subtract, it means multiply, right? I can put it in parentheses if that makes it better. What you got?
Mine says 37.
37? That's right. That's right.
Oh.
See, you don't like that because you're not used to hearing that number, are you? So if they tell you, if you go somewhere in another country and you say, well, the high today is 40, you say, ooh, that's going to be cold. No. 37 is 98.6 Fahrenheit, right? If it's going to be 40 out, it's over 100. 40 degrees in all the other countries, it's over 100. So I don't want you ever to be so dumb. I don't want you to be dumb about this. The rest of the world knows this. Yeah, you might say, that's not fair. I have to know the Fahrenheit scale and the Celsius scale. Too bad. They don't care about the Fahrenheit scale. They're not going to be taught that. They don't care. Celsius. All right, let's do one more. What is a comfortable room? I'm going to go to Italy when I'm a senior, and I want to know what's a comfortable room setting for my thermostat. And I'm going to change this to 72, okay? I think 72 is more likely than 77. So put 72 here. First thing you do, subtract 32, 5 nights. Yeah. All right, what's a comfortable room? Did you already do this one? Anybody? Raise your hand as soon as you get done. Oh, you got it? Daniel.
22.2.
That's it. If I go to Italy and I'm going to set thermostat around 22, that's going to be good. That's a good one. So I don't want you to feel like you shouldn't know any of this. You should know the bare minimum of this. Got that? I'll show you a little trick also. What if you thought you memorized this wrong? Can you at least remember that water freezes at 32 Fahrenheit and that's 0? Can you remember that? Well, let's put 32 in here. Ready? 32. First thing you do, subtract 32. 32 minus 32 is 0. 0 times 5 9 is 0. Ding, 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 ding. I must have done it right. Because 32 Fahrenheit is 0 Celsius. All right. You got about 30 seconds. Let's look at the other one, okay? And I'll be done. We're done for the day. The other one is absolutely backwards. Watch this one here. It adds and subtracts. Adds or subtracts first, then multiplies. Not this one. This one's going to take Celsius and not add or subtract first, but multiply. It's not going to use 5/9, it's going to use 9/5. Now watch right here. I'm not going to subtract 32. I'm going to, wow. If I memorize this one and I do everything backwards, now I have both of them memorized. Got that? Okay. All right. Good job. Have a nice weekend.